Welcome to this explainer. Look, if you're building enterprise web apps, you already know the drill. Keeping your architecture clean and your tests fast is a constant, everyday battle. So today, we're exploring the evolution of modern Angular. We're going to see how the framework has dramatically shifted its architecture and testing paradigms to give us developers some truly unprecedented power and efficiency. I absolutely love this quote from Andy Hunt's Law of Design. If you can't rip every piece out easily, then the design sucks. It perfectly sets the stakes for us today. For years, web frameworks kind of allowed us to unintentionally tangle our code into a huge mess. But modern Angular, it's been rebuilt specifically to ensure decoupling and maintainability. The goal is that you can easily swap out pieces of your application without bringing the whole system crashing down. Okay, let's dive into this roadmap. First up, the enterprise web evolution. Second, the reactive programming paradigm. Third, the standalone component revolution. Fourth, next-gen Angular testing. And finally, testing signals and components. Section 1. The enterprise web evolution. A brief history. Our architectural needs have just exploded over the years. Think back to 2006. That was the jQuery era, which smoothed out those awful browser inconsistencies. Then through the 2000s, we relied heavily on server-side model view controller setups. But as users started demanding richer, native-feeling experiences, the 2010s really pushed us toward complex client-side architectures known as rich client MVVM. Now, the big problem with those early thick clients was unmanaged complexity. The whole kitchen sink analogy really hits the nail on the head here. When presentation logic and business logic become unintentionally commingled, simply replacing the sink becomes impossible. You literally end up having to renovate the entire kitchen. Have you ever had to rewrite an entire feature just because the UI was too tightly coupled to the data? Organizations waste millions doing exactly that, all because they fail to maintain a disciplined architecture. And this brilliantly illustrates the solution: a decoupled model view model, or MVVM architecture. By separating the client from the server via an API, we structurally enforce that separation of presentation logic from business logic. Sure, it takes a bit more code up front, but it ensures that you can replace your UI, your kitchen sink, without tearing down the whole house. To keep everything reliable at an enterprise scale, Angular leans on TypeScript, which acts as a transpiler. It essentially transforms modern syntax into universally compatible JavaScript. This is huge because it lets us use the absolute latest features, while gracefully bridging the JavaScript feature gap for older environments. It's really the bedrock of Angular's maintainability. Section 2. The reactive programming paradigm. The paradigm shift. Now, what's really interesting about this slide is the contrast between imperative and reactive programming. Doing things imperatively, like getting hot water, requires 6 heavy, sequential steps. You grab a hose, spray water, check the initial state. It relies entirely on the previous steps. But reactively, you just turn on the faucet. Reactive programming treats everything as an asynchronous data stream, so you can write highly composable, completely independent logic. Enter signals. Angular rolled these out in version 16, and they supercharged this entire concept. They're a new paradigm for fine-grained reactivity. Honestly, it's amazing how they track state changes so seamlessly. They completely bypass the heavy performance bottlenecks we saw with older reactive methods or traditional change detection loops. It's just an incredibly efficient way to manage state. Section 3. The standalone component revolution. A lightweight revolution. We've all wrestled with end modules, right? A total developer pain point for years. Well, standalone components introduce a lightweight API that finally makes end modules optional. Components can now directly reference their dependencies, whether that's other components, directives, or pipes. It is such a massive relief to build this way. It is literally night and day. The old way forced us into these rigid structures with high boilerplate, creating massive shared modules just to reuse really simple elements. The new way is incredibly lightweight. By importing dependencies directly into the component, we hit true low coupling. Your components are finally entirely self-contained. Section 4. Next-gen Angular testing. Testing with Vitest. Legacy Angular testing was, well, let's be real, it was notoriously slow. You needed heavy component fixtures and clunky Karma setups just to test simple logic. But today, we use Vitest. It runs unit tests in a blazing fast Node.js environment. And here's the best part. Because basic signal primitives like writable and computed signals don't even interact with the DOM, you don't need to create a component fixture to test them. Seriously, it feels like a newfound developer superpower. The Angular CLI handles your Vitess setup so smoothly now. There are a few key configurations you manage directly in your angular.json file, things like include, exclude, browser tests, and coverage. But you really want to pay special attention to the providers file property. This lets you export a default array of Angular providers globally for the test environment. It makes your individual test files so incredibly clean.
Section 5. Testing signals and components. Practical execution.
Let's move to and see how this builds out practically. To test these standalone components efficiently, we use shallow testing. It flows like a very logical recipe. First, we provide a mock HTTP backend using provide HTTP testing. Second, we mock the router with provide location mocks to simulate route changes. And finally, we use the override component method on the testbed to rip out real component dependencies and just swap them with simple mocks. This completely isolates the component. But wait, as you're writing these tests, you might hit a pretty common pitfall. What if a signal change doesn't actually trigger an expected update? It's super easy to assume that when a signal state changes, a computed signal returning that state should also naturally change. But what if it returns an object reference and the actual update is obscured? Well, you can build a really clever utility for this right into your tests. You just create a computed spy. It's a custom wrapper around your computed signal that simply increments a counter every single time its computation function executes. Then you just check that counter in your assertions to prove definitively that the signal fired. But that brings up a much trickier situation. Effects. How do we track effect invocations? See, effects are tied to the renderer, and unlike basic signals, they absolutely require an injection context to run. So the crucial point is, you don't actually need a full component fixture just to test an effect. You can use two static testbed methods that are built right into Angular. First is flush effects, which manually tells the current effect scheduler to run all effects that have an updated dependency. Second is run in injector context, which executes your signal initialization safely inside the environment injector. Want to speed up your workflow even more? Here's a fantastic advanced utility tip right from our sources. Tests involving effects often require repeated, super verbose calls to flush effects. You can actually automate this by wrapping your signal inside a JavaScript proxy. The proxy intercepts every method call, like setting or updating the signal, and automatically calls flush effects immediately afterward. And as the source notes, using a proxy brilliantly avoids the nasty side effects you'd normally get from traditional monkey patching. We've covered a ton of ground today, from the high-level evolution of enterprise architecture down to the granular precision of testing signals in Vitest. So I want to leave you with this somewhat provocative question as you evaluate your own codebases. Are your tests actually proving your logic works, or are they just proving your legacy architecture is way too hard to mock? Modern Angular gives us the tools to decouple, isolate, and test beautifully. It's time we leverage them. Thanks so much for joining me on this explainer, and happy coding.